All right. Now 1.4 is the section for power, defining a power. Well, I believe this is not a new concept for ninth graders. You definitely in grade 8 or could even be in grade 7, you have encountered this concept. But let's just talk as if we never heard about it. So now, what does a power mean? A power means when first some of the human beings realize, and for example, if I have 8 multiplied by 8 and multiplied by 8. Now this kind of writing is rather tedious, like 3, 8 multiply themselves all together. So then somebody came along, just say, hey, why don't we define it, and then just use a different notation. Notation means it's man-made. So then, why don't we just say that means 8 to the power of 3? So that means this is just a exponential notation. Now here, the 8 is called the base, and the 3 is called the exponent. Then the whole thing, 8 to the power of 3, this whole thing could be called a power. Now, if I like to use something more abstract to write about this, it could be written as a to the power of b, or another way to write, I could also say b to the power of e. So that means this one is a base. Now this one is exponent. And then that's just a more abstract way to write it. Okay? So then in this case, one thing we needed to pay attention is so-called the product of negative numbers. What does that mean? That means a negative 2 multiply a negative 2. This is multiplication is called the product of this number, which is negative 2. Then multiply by another negative 2. Then written in an exponential form, that is negative 2 to the power of 3. So therefore, when the base is a negative number, we have to be very careful. When the base is a negative number, this bracket here is very important because the negative 2 to the power of 3 and negative 2 to the power of 3 does not, oh, this one is equal. As a matter of fact, this one is equal. However, negative 2 to the power of 4 does not equal to negative 2 to the power of 4. You see this? When you say it, it doesn't sound like we're talking about different things. Sounds like we're talking about different things. Talking about the same thing. But when you write it out, this is absolutely not true, because any negative number as a base, if the exponent is an even number, and then your result is a positive number. It's a positive number because negative multiplied by another negative, that becomes a positive, right? So if an even number that goes pair in the very end, it becomes a positive. But if it's an odd number, such as a small one is 3, that means this one makes a positive, but then the positive and the negative, that makes a negative. Okay, so now take a look at this. So if the base is negative 2, you have to have this parenthesis, and then that equals to positive 16 because this is a power of 4, which is an even number. Now, your base is only a positive 2, but in front of it, it's got a negative number. Then that comes, in the end, is a negative 16. Now, this one again, it is still means this is a power, this one is a power, but in head of it, it is a negative sign. So then it's negative 16. Now, the next one of the section is to talk to us about the power, the exponent of 0 and 1. Now, the exponent of 1, that is easy to understand because 1 to the power of 1 means 1 just multiply by itself, or, just multiply, it just not even multiply by itself. The multiply, there's nothing. It's just like A, it's just all by itself. Then, of course, it just equals to A. Now, something to the power of 0 equals to 1. And now why? You should absolutely ask why, okay? Now, we're going to save the why until we come to the exponent law. Then that time we'll prove why this is something to the power of 0 is 1. So it doesn't matter. You can have negative 4 to the power of 0, that is 1. You can even have like 2 to the power of m over 3 to the power of p. As far as this is to the power of 0, then that's just 1. Right? All right, so now here, one thing to be noted is that 0 to the power of 0 is undefined. I remembered a couple of classes ago, I asked a question to have students to give me just, a couple of examples about irrational numbers. And one student says, how about that? Isn't this an irrational number? Well, as a matter of fact, this one is not a rational number, nor an irrational number. This one is undefined. Okay. Now, these examples is really straightforward, simple enough. So now take a look at exercise set. Now, these questions really not interesting. This is all not interesting. This is a writing to exponential notation, not interesting. But most of you should just quickly go through it to see what's going on. Okay, now evaluate. Now pay attention. This is a negative number as a base, but that's even number. So in the end, it should be a positive number or negative number. Now this one, the base, as a matter of fact, is just 3. So it's a positive 3. But ahead of it, it is a negative sign. So then that should be positive number, negative number. You please ask yourself and be very clear about what's going on here. Now, this one, negative 2, as a base, and it's got an odd power or odd exponent. Then this one is a negative number or positive number. And then on top of that, there is a negative sign ahead. All right? So these questions are interesting. Now these ones, try to do these questions because it's all got this power of 0 here, okay? Now this is called repeated factor. Repeated factor means, sure, that equals to 2 multiplied by 2, multiplied by 2, multiplied by 2. So these called the factor of this exponent, right? Then this question is interesting. So definitely everybody please try this question. And this question is even further interesting. I definitely would like to see how you do this, okay? Other than that, just have fun. Thank you for watching.